Welcome to my Chapter 3 video lecture for CIS 212, VisualBasic.net. Before we get going, I want you to pull out your textbook and I want you to turn to page 125. There you'll see Step 2, Figure 3-14. They're going to want you to start putting these switches in your code right above your class statement. Option explicit on, option infer off, option strict on. That's going to force you, unlike the last two chapters, to explicitly declare variables, to explicitly convert one type to another if it can be converted. There's an easier way to do that than put that in every project, which is what you'd have to do. So what I want you to do is open up Visual Studio and go to the Tools menu and scroll down to the Options selection. Okay, you'll see environment probably is what you'll get this. Go to Project Solutions, go to VB Defaults, and here are those settings. And if you'll go ahead and set this before you create a project, I mean, once you set it, it's going to be there. Then you don't have to worry about putting that in every file because you're going to ultimately forget to do it. And then when I see it and I make you turn it on, your code's probably going to be broken. So let's just do this and get it over with. Option explicit is on. Option strict should be set to on. Option compare can be left at binary, and option infer needs to be set to off. These are your settings. On, binary, off. Now, if you close the Visual Studio and open it back up and go back in there, it will have remembered those settings. So that's what we're going to do to start with. So now you can jump back to page, whatever it is, 115. We're going to talk about data types a little bit. VB has quite a few. The Boolean, as you already know, is a true-false value. It has one of two possible states. It's either true or false. There's no maybe in between in there. Char is a Unicode character. It's one single character. That's all it holds. It's 2 bytes. Date is a date time. You use that for grabbing stuff out of databases and things of that nature. Don't use it that much unless you're doing database stuff and web stuff. Decimal will hold an extremely large or extremely small number. You can see the number of significant digits. It's pretty big. And it's 16 bytes, so it's twice what a double is. Okay. If you need a really big number or a really small number, you can use a decimal. But other than that, I'd use a double. Double is just a number with a decimal component. It's 8 bytes in size. Integer is a positive or negative whole number with no decimal component. A long is just a bigger integer. As you can see on page 115, it's 8 bytes, so it's twice the size of an integer. And it holds roughly more than twice this bigger negative or positive number. An object has a lot of overhead with it, but you can use it when you don't know what kind of object you're dealing with. All right, that's why it's got a lot of overhead. So it does have its place. Short is an integer of 2 bytes, so it's actually half the size of a regular integer. A single is a number with a decimal place. It's 4 bytes, so it's equivalent to the float in C# or C++. It's roughly half the size of a double. And then your string can hold up to 2 billion characters, assuming you have enough memory to use it like that. Okay. Let's see. What else can we talk about before we get going here? You should already know how to do naming of variables, but if you don't, you need to read this. We use camel casing. They have prefixes in here that start the variable name. I have a list of those under Student Resources and Blackboard. I've already talked to you about the fact you probably need to have those out in front of you. I don't mind you using the book nomenclature as long as you use something. I like mine, but they're actually doing a lot like I'm doing in mine. So, and I got mine from business and industry. Different companies use different naming conventions. So just as long as you don't leave the text box 1 or form 1, that'll get you a quick 0 in my class. Got to rename all those standard objects. So this BLN tells the programmers who are looking at the code that you've written or somebody else has written that this is already, they know what type it is without having to run down the declaration. They know it's a Boolean, and it has something to do with insured or insurance. DEC for decimal, gross pay. Double DBL sales, well, that's going to have a decimal component of 8 bytes, and it's going to hold sales numbers. Integer num sold, so that's an integer. STR means string, as you can see on the ID there on page 116, STR first name. So I'm going to let you kind of go through that. You should know what the rules are. You can look down here at figure 3-5 on page 116, and you can see the do's and the don'ts of variables. All right, I'm going to go ahead and quickly create a project here. I say quickly because I don't know what's going to happen. Let's see, I want Visual Basic this time, and I want a Windows Classical Desktop, Windows Form app. Find my, excuse me, my device. I'm doing videos here, so it's going to do lectures. I think I'll go outside of that. I'm just putting this somewhere so I can reuse it later. Let's see, I'll put it here. 212, there we go. And I'll call this chapter 3. Lecture, there we go. And in a few minutes, hopefully it'll build. This is going to be a multi-part lecture, I'm sure, like the rest of them. While we're waiting, if you look on page 117, you'll see examples of variable declarations. Now, remember, in my classes, you always, I don't care what the book says, do not send me projects where you have not initialized your variables in the declaration statement. If it's an integer, you use a 0. If it's a double or a decimal or a float, use a 0, or excuse me, a single, or long, excuse me. Use a 0.0. If it's a Boolean, use a true or a false. Okay, if it's a string, use string.empty. Character, I think it's a space in single quotes. So always give it a default value. And the reason for that is it's just really good practice to wipe those memory locations out because they're going to have garbage in there if you don't do that. Okay, and then they've got 118, they've got more syntax things here. And I'm going to just basically show you how to do this. Let's see, there's my form. Let me go rename it real quick. Need to get the habit of doing this. Always do this. Mine's going to be form main because it's my main form, and the prefix for form is FRM. Yes, we want to rename all instances of that. Okay, select my form, go to properties. There's form 1. I'm just going to call this chapter 3. I always need to rename that to something. Let's see where the startup position is. Oh, this is all grouped. I don't want it grouped. There we go. Windows state, startup position. There we go. Center screen. So those are the 3 things you should do first. Now your toolbox is where you grab your controls. I know I'll need a button. I'll need a label, more than one, but I'm going to put this in here. And then I will need a text box, pretty much always. And I'm just designing this as I go. I don't know how it's going to turn out. Okay, there's one there, and there's that. This needs to be taken over a bit. Now your labels, I like to set, let's move this up a bit. Maybe a little. I like to set it auto size defaults, and I think I've already explained to you why, because you don't do that and you take text out of it and click off of it, it's hard to tell where it's at. You have to do a window select to find it. So auto size, I set defaults. There are times when you want to use auto size that way if if you're doing some strange things. All right, and I also want to do text alignment. There it is. I like to use middle left. Why they set top left to default, I'll never know because the text box doesn't do that. All right, and I'm going to pull this back just a bit. So now when I copy that, and I got to rename these. Let's see. I'll call this button calc. Don't know why. Calc, C-A, let's use ampersand A. That's your alt key combination. Calculate. There we go. And I'll call this button calc's going to be the name. Remember, the name and the text property are totally different things, not the same. All right. Now I'm going to create a click event here. Well, let's go ahead and rename this. Text. I'll call this numbers. Number 1. All right. Label will be label 1 because it's associated with text box 1, or number 1, should say, not text box 1. Label 1. Just get rid of that default name, whatever you do. And I'll just call this first number. All right. Middle left. Yeah. Okay. It needs to go up a little bit. Maybe it needs to go down a little bit. I can't tell. It looks like it's not middle left, but that's just me, I guess. All right. So there's that. We've got that set up. We have that set up. And we have this set up. So I'm going to go ahead and I'm going to double click on this so I can open up a click event in the code view. And there it is. So let's declare some variables. Now, in a little bit, we're going to talk about scope and lifetime. This particular, it's on page 123. This particular variable is inside of a click event, which is a subroutine or a function or a method. So it has local scope. Anything I do in here will not be accessible in the main class. Okay, that's just the way it goes. That's just what we call it's local to this method. So no variables or code in here exists really until this particular subroutine or method, this event handler, is executed. At that point, everything's created, everything's live, but can't be seen from the public class, form main. And then when it ends, it all kind of goes away. So it's sort of like temporary. It has block scope, the block of this subroutine. All right, let's do an integer. Oh, let's do a double. All right, so it's dim. Now, in the old days, where this comes from, just for a little trivia, dim is short for dimension. And that's what they used to call creating variables, dimensioning memory or dimensioning a variable. That's a holdover legacy issue. That's just the way they do it. No sense of changing it after 50 years, 40 years, however long it's been out there. Yeah, it's been out there, well, maybe 38 years. Dim, then the variable name. I'm going to call this, what am I going to call it? Price. So I'll do DBL for double and then price. Okay, got to give it a value. Initialize it. 0.0. Oh, wait a minute. Sorry. Dim double price as, and then you got to give it a type, double. I'm getting confused with my other languages here. All right, now, dim, the variable name, as double, and I give it a value. Now, you all know, hopefully by now, from my classes, especially the 150, that I drilled into your head what a variable really is. It's a pointer to a memory location. Because it points to the beginning hexadecimal address of memory, the assignment statement takes what's on the right over here and sticks it in the memory location pointed to by the name on the left that the compiler has just allocated and attached this name to or pointed this name to. That's how that works. So whenever I use the variable name or the object name, I have access to that object or that memory location. All right, so now we have this. If I wanted to declare an integer, I could do dim int year. It's not going to be a it's not going to be 2017.5. It's going to be 2017 as integer assignment 2017. Oops, here goes my C# stuff. We don't have semicolons as line terminators in VB. Okay, so that's how that works. And you can do it for strings. The string is going to be dim str name as string assignment operation, and then quote, because it's a string literal in this case. Right, that's one way. Or you can make, if you don't know what's going in there, you can just use the string object, which has an actual method called empty, and that will just make it an empty string. Okay, so whenever you have a valid object name and you press the dot operator, IntelliSense will pop up and show you all of the associate or available properties and methods that you can use by using this entity here, this object. Okay, and I could go on with bool and all that, but you can see that on page 118. All right, so I'm going to delete these. I'm going to leave the price in here though. Let's go back to the form and see what the name of our text was. Text box, text number 1. Okay, go back to view code. If you remember, before we set those options, switch settings, explicit, on, infer, off, and all that kind of stuff, you did this sort of thing in various chapters. So it's text in the previous chapters, number 1 dot text, right? Assignment double price. It's not going to let you do that anymore. Why? Because you're trying to take a number of type double and push it into an object that's expecting a type string. It's apples to oranges. You cannot do that. You could get away with that in the first 2 chapters because they let you. You can't do it anymore, and you shouldn't be doing that. Okay, now that, like I said earlier, if it were my textbook, I would have never even talked about. I might have mentioned it in one paragraph that they used to do that. We would have done this from the beginning, but I didn't write the book, so we have to go with what we have. All right. So how do you do that? Well, there are different ways to convert. I mean, you've used, if you've read the chapter and worked through this, you already know about try-parse, and you should always work through every example in these chapters before you listen to my lecture, and certainly before you do the projects. Okay, that's, like I said in the beginning, that's the way you're going to have to do it. And if you look at the course schedule, you'll see it says work through chapter work A, B, and C. Right? That's lesson A, B, and C for each chapter. So you got data type dot try parse. You have a string and a numeric variable. So you want to take maybe convert from a string to a number. See that? On example 1 on page 120 under try parse method. Now that's going from a string to a number. And that works fine. But what if you want to convert from one type to another, whether you want to go from a number to a string or string to a number? My favorite way of doing this in all of these languages, and that's on page 121, the convert class. All right, that's my favorite. You need to know about try-parse. You need to know how to use it. But that's really just going always from a number to a string, not from a string to a number. There's another way to do that, and you can say, if you have a string data type, you can, or a numeric data type like a double, you can do double pay dot to string and assign that into a string. That's another way to do it. And you can do casting and that sort of thing. But the convert method is really the easiest and the most efficient, and certainly the most robust, in that you can do a bunch of different types, one type to another. So let's look at convert. You simply type convert dot. All right. Now what type are we assigning into? That's what you need to look at. Whatever we got over here, it needs to be a string before this assignment can take place. Both of these have to be strings for this to be a valid assignment. You understand? Because the text property is of what type by default? String, always. Text boxes only contain strings. Now you pull stuff out of them from a string, and you convert it to a number, and you do some math on it or whatever, and then you have to convert it back to a string before you output it, either to a label or a message box or whatever that expects a string. So remember this when you're working with Windows Forms. Typically, not always, but typically, you start out with string data coming from text boxes that the user enters, or you pull it in from somewhere else, a database. And then you convert it into numbers sometimes, so you can do math on it. And then you have to convert it back to a string so that it can go back into the text property of the object of the, an output label or labels, which is of what type by default? String. So it's string to number to string, typically, not always. But that's something you need to get used to. All right, so I've got convert, right? Dot operator. What are we going to convert to? Well, we want to convert to a string. So to string. All right, now this is a method, so you have to have opening and closing argument lists. And there are 37 different implementations of this. Let's see what the second one is. All right, value is byte, value is char, value is date. Now I already know this. Value is double because my data is held in what? A double. Okay, so I just stick it in here. You see how many different conversion methods there are there? And that'll take whatever's in this double here, convert it to a string, and stick it into the text property. So I've got a string going into a string, which is exactly what you want. Anytime you do anything, you have to be able to convert. All right, from one to another, explicitly. And if you go back and look, option explicit on, option strict on, option infer off. You don't let the compiler guess anymore. That's what infer means. It's guessing for you, and you don't want it to do that. It's implicitly converting. All right, this is the end of part 1. We'll pick it up in part 2 shortly.